So this is the mathematics paper from 2015. Number 1. Fill in the following blanks with the correct numbers. 1. When a is greater than 0, then what is the range of x that satisfies the following inequality? Here is the inequality. First thing you have to do is to factorize, extract a from every term. We can factorize the part within the bracket even further. And at this point, let's draw a graph. It's going to be a very rough sketch. And from the question, we know that a is positive. So the graph is going to look something like this. And the roots will be +1 and +2. And this part of the inequality says that the value of this whole expression has to be below 0. So we are talking about this part right here. So the range of x is going to be between 1 and 2. So the answer will be number 2. So the first thing you have to do is to move this term to the right hand side. 4 is 2 to the power of 2, so we can express it like this. And we can distribute the 2, 6x minus 2. So at this stage, we can see that 6x minus 2 has to be equal to 5x minus 4. The rest should be simple. So the answer is x equals minus 2. Number 3. So I'm going to give you a little trick. If a number is raised to the power of a log expression and the base of that log expression is the original number, then the answer will be equal to this number. So this whole expression is equal to 5. Number 4, when alpha and beta are the solutions of the quadratic equation, then alpha squared plus beta squared equals blank. Alpha minus beta squared equals blank. So in order to solve this question, you have to know two facts. First of all, alpha plus beta equals minus b over a, and alpha times beta equals c over a. And a, b, c refers to the coefficients of these terms. So a equals 1, b equals minus 5, and c equals 3. And the questions we want to solve are these. To solve this, we have to do a little trick. So basically, I wanted to be able to factorize this expression somehow so that we can convert this expression into a combination of these two expressions. So now, what we need to do is substitutions. So the answer to the first question is 19. For the second question, we have to expand this. From the first question, we know that this part of the expression is equal to 19, and we of course know what alpha times beta is. So 19 minus 6, which is 13. Number 5, when the magnitude of vector A is 1, and the magnitude of vector B is 2, and the magnitude of vector A minus vector B is equal to root 7, then the degree measure of the angle between vector A and vector B is blank degrees. So first of all, let's draw some vectors. Since we don't know the components of these vectors, let's say this is vector A, and let's call this vector vector B. If you're not familiar with vectors, I can quickly show you how you can derive this diagram. Again, this is vector A and this is vector B. To get minus vector B, you basically have to flip it 180 degrees. So you get this minus vector B, And to go from vector A to minus vector B, let's rearrange the vectors a little bit. So this is vector A minus vector B. Vector A minus vector B is going to be this vector. And because vectors can be freely moved around, as long as you don't change the direction or the magnitude, you can basically move this vector and put it here, like this. And that's how you get this diagram. So basically, what we're dealing with in this question is a triangle with the sides 1, 2, and root 7. And we need the angle between vector A and vector B. The angle we're after is this one, and let's call it theta. And to find the angle, we can use the cosine rule because we know the length of all the three sides of a triangle. Cosine theta is equal to 1 squared plus 2 squared minus root 7 squared over 2 times 1 times 2. 1 plus 4 minus 7 over 4, which is minus 2 over 4. Cosine theta is equal to minus 1 over 2. So the rest should be fairly quick. So we know the angle is 120 degrees. And that's it. Number 6. When ABC is a triangle where angle A is 30 degrees, then the sine of angle B plus angle C is blank. Okay, so this is what we know so far. And we're looking at a triangle like this. Based on the fact that angle A is 30 degrees, we know that angle B plus angle C must be equal to 150 degrees. So sine 150 degrees is 1/2. Number 7. How many multiples of 3 are there among integers from 100 to 200? The answer is blank, and the sum of those multiples of 3 is blank. Between 0 and 200, there should be 66 multiples of 3, because 200 divided by 3, 66 point something. And between 0 and 100, there should be 33 multiples of 3. 66 minus 33 is of course 33. So between 100 and 200, there are 33 multiples of 3. And we have to find the sum of all these 33 multiples of 3 between these two numbers. And we can express that using the sigma notation. So basically we have to plug in the value of I into this expression and increment I by 1 each time, all the way up to 66. We're going to put the values of I into these brackets, like this, the second sigma. And now this sum is contained within this sum, so we can basically cancel out this part. And next, we have to add all these numbers together, but there's a trick. Add the first number and the last number together. 34 plus 66 is 100, 35 plus 65 is 100, and so on. So we get pairs of numbers that add up to 100. All we have to do is to work out how many pairs we get and what the number in the middle is going to be. 66 minus 34, which is 32. There should be 16 pairs of numbers that each add up to 100. That means that the number in the middle is going to be So the answer is 4,950. Number 8. When x cubed plus ax squared plus bx plus 5 is divisible by x minus 1 and has a remainder of 5 when divided by x minus 2, then a equals blank and b equals blank. I'm sure there are much easier ways to do this, but let's try the most tedious way. That is, let's actually divide this polynomial expression with these divisors. X squared times x is x cubed. X squared times minus 1 is minus x squared. So we have to subtract these two numbers. So we get a minus minus 1. And we continue doing this. So this is the end result, and this whole expression must be equal to 0 because when divided by x minus 1, the remainder must be 0. So if we tidy this up, we get a plus b equals minus 6. And let's try the next divisor, x minus 2, the same stuff. And this whole expression must be equal to 5 because when divided by x minus 2, the remainder should be 5. So we end up with these two equations. So we basically have to solve them simultaneously. So we know that a is plus 2. That means b is going to be minus 8. Number 9. Let f of x be equal to the absolute value of x squared minus 1. F of 0 equals blank. And then we basically have to find the definite integral between 0 and 2. So let's first think about x squared minus 1 without the absolute value sign. And let's sketch it. You should be familiar with this graph. And when you have the absolute value sign, it basically means that everything below the x-axis must be flipped up. So we get a graph like this. 1, minus 1, 1. So when x is equal to 0, the absolute value of minus 1 is of course 1. And you can see that in this graph as well. And then we have to integrate this. But before we do that, we have to do a little trick. So we need to find the area between 0 and 2. So the area here and here. So for this area, we can imagine that we are dealing with a function that's flipped upside down, like this. So this is going to be x equals minus x squared plus 1. So this whole area is equal to 2. Number 10. Assume that a, b, and c are consecutive terms of arithmetic progression. When a plus b plus c equals 24 and ABC equals 440, then what are the values of A, B, and C? The word arithmetic progression basically means that from one term to the next, a fixed amount is either added or subtracted. Let's say that the difference between these terms is D. So we can express this equation in the following way. A plus D plus A plus D plus D equals 24. 3A plus 3D equals 24. Divide everything by 3 and we get A plus D equals 8. And we can do the same with the second equation. And we know that A plus D is equal to 8. And we ended up with a quadratic equation. If A is equal to 5, then D would be 3. On the other hand, if A is 11, we would get a negative number, but the question said C is greater than B and B is greater than A. So that means that A should be 5 and D is 3 And because A, B, C are consecutive, that means that A is 5, B is going to be 5 plus 3, which is 8, and C is going to be 8 plus 3, which is 11. Section 2. On the plane xy, there are 4 points, the equation of the straight line AC. So let's plot these points. And we need to find the equation of this straight line, which doesn't look straight. And because we know the y-intercept, we only have to find the slope. So the slope is going to be 4 minus 3, y equals minus 3 over 4 plus 3, which can also be expressed like this. Multiply each term by 4. Oops, I forgot to put in x there. Move everything around. 3, 4, 12. The next question. The coordinates of the circumcenter of the triangle ABC are this. You can get the circumcenter by drawing a perpendicular bisector of each side, like this and this. And the circumcenter is the point at which all the 3 lines intersect. And in this graph, this triangle is symmetrical about the x-axis. The x-axis is actually the perpendicular bisector of the side AB. So what we need to do is to basically find the equation of the perpendicular bisector of AC and get the coordinates of the intersection between the x-axis and the perpendicular bisector of AC. From the previous question, we know the slope of AC, which is minus 3 over 4, and this line, and let's call it L. The slope of AC times the slope of L must be equal to minus 1. So the slope of L is 4 over 3. And we need to find the coordinates of the midpoint between A and C, which is going to be quite easy. So the midpoint, let's call it L. The horizontal distance between A and C is 4, so the x-coordinate of L must be 2, and the vertical distance between A and C is 3, so the y-coordinate of L must be 3 over 2. So we now have to find the equation of a straight line that goes through the point L, which has the slope 4 over 3. And let the y-intercept be B. So we now have the equation of L. Circumcenter is on the x-axis, so we have to plug in y equals 0 into this equation. So the x-coordinate of the circumcenter is 7 over 8, and of course the y-coordinate is 0 because it's on the x-axis. Number 3, point D is the intersection of bisector of angle ABC and x-axis OD to DC is equal to this. And the coordinates of the inner center of the triangle ABC are these. Let's draw a bisector of the angle ABC, and D is at the intersection of this bisector and the x-axis. And we need to find the ratio OD and DC. This question is really easy. We know the length of OB, 3, and we can calculate the length BC easily using the Pythagorean theorem. 4, 3. So BC is 5. And we know that this ratio, OD to DC, is going to be equal to 3 to 5. And next we have to find the coordinates of the inner center of the triangle. Inner center is basically where the bisector of each angle meets, like this. OC is actually the bisector of the angle ACB, so we basically have to find the coordinates of D here. We know that the distance between O and C is 4, so we're going to divide 4 into 8 parts, 3 plus 5, and we're going to move from 0 to 3, which is going to be 4 times 3 over 8, which is 3 over 2. So the x-coordinate of D is 3 over 2, and the y-coordinate is of course 0 because D is on the x-axis. So that's another question done. Section 3, the last section. The line A is tangent to both the parabola B and the parabola C. Point P is the point of tangency of the line A, and B. Point Q is the point of tangency of A and C, and point R is the intersection of these two parabolas. Number 1. The constant k is equal to blank, and k is the constant in line A. So in this question, line A touches these parabolas at points P and Q, which means that these parabolas have the same slope at points P and Q. So what I'm going to do is to find the derivative of each of these equations. dy dx is 2x minus 5, dy dx 2x plus 3, and because the slope of line A is 1, let dy dx be equal to 1. So now we know the x-coordinates of P and Q, so let's find the y-coordinates as well. In order to do that, we substitute these values into the original equations. Y equals 9 minus 15 plus 7, which is 1. Y equals 1 minus 3 minus 1, which is equal to minus 3. Coordinates of P are 3 and 1, Q minus 1 and minus 3. So to find the value of k, we just have to substitute these values into this equation. 1 equals 3 plus k, that means k is equal to minus 2. So let's rewrite this equation, x minus 2. And we actually solve the next question except for the x-coordinate of the point R. And to find R, on the left hand side we have the equation for B, and on the right hand side we have the equation for C. Minus 5, minus 3, minus 1, minus 7, minus 8, minus 8, x is equal to 1. So the x-coordinate of R is 1. 1 plus 3 minus 1, 3. The x-coordinate is 1 and the y-coordinate is 3. And the final question, the area surrounded by the line A and the parabolas B and C, that is the area enclosed by the straight line and the two parabolas. One annoying thing about this question though is that the point Q is below the x-axis. So to make this question simpler, let's shift everything up by 3 units. In order to do so, we are going to add 3 to the y-coordinates. And of course we have to update these equations as well. X plus 1 plus 10 plus 2. Now that everything is adjusted accordingly, let's do some integration. So my plan is to find the area here, and then the area here, and finally subtract the area here. So let's go. Between 1 and 3, the equation is going to be the updated version of B, plus between minus 1 and 1, and we need the updated version of C. And the area shown in red, 3 minus minus 1, which is 4, and the height of this triangle should be 4. Area is 1 over 2 times 4 times 4, which is equal to 8. We have to subtract 8 at the end. Let's go. (16/3). And that was it. If you have any questions or comments, please let me know in the comment section.